Hello guys, in today's video we are going to handle a complicated probability problem. So stay with me as I give you all insights about this particular problem. And the question says that a child is allowed a lucky dip from each of the three boxes. One box contains 10 chocolate and 5 mint. One box contains 8 apples and 4 oranges, and the third box contains 7 dinosaurs and 3 turtles. Event A, B, and C are defined as follows. A. The child gets a chocolate and a dinosaur. B. The child gets a mint or a turtle or both. C. The child gets an apple. List the events A, B, and C and find Roman 1, the probability of A intersect C, Roman 2, the probability of A intersect B, Roman 3, the probability of B intersect C, Roman 4, the probability of A union B, and 5, the probability of A union C. So without much ado, let's start by collecting the data of items in each box. So in box number 1, we are going to have 10 chocolate and 15 mint. So CH represent chocolate and MI for mint. So in this case, we have that the total sample space will be 10 plus 15. So the total number of items in box 1 will be 25 items. And for box 2, we'll have 8 apples AP and 4 oranges OR. So the total number of objects in box 2 will be 12. So 8 plus 4, 12. And in box 3 we'll have 7 dinosaurs and 3 turtles. So the total number of items in box 3 will be 10. 7 plus 3. Now, before we get into the probability of selecting either a chocolate, a mint, apple, orange, dinosaur, or turtle, the first choice that child has to make is to choose which box to select an item. So we need to first of all get the probability of selecting either box 1, box 2, or box 3. Then can he start selecting an item. So in this case, to select a box, we have 3 boxes and each of them have equal probabilities. So in this case, the probability of selecting each box will be 1/3 because it will be 1 box out of 3 boxes. So the probability of selecting the first box will be 1/3. The probability of selecting box 2 will be 1/3, and the probability of selecting from box 3 will be as well 1/3. So the next thing is that if you are selecting from box 1, then you can only draw a chocolate or a mint. So in this case, the probability of getting a chocolate is 10 out of 25. The probability of getting a mint is 15 out of 25. The probability of drawing from box 2, you can either have an apple or an orange. So from box 2, you can either have 8 out of 12 apples or 4 out of 12 oranges. So in this case, we have box 3, and the box 3 contains mint, turtle, and dinosaurs. So the probability of getting a dinosaur is 7 out of the total number of items in box 3, which is 10, and the probability of getting a turtle will be 3 on 10. Correct. Now, for us to get the actual probabilities of A, B, and C, we can therefore come up with what? A Venn diagram. I love using Venn diagrams so much because they help simplify the questions at hand. So the first thing we are going to draw is the Venn diagram of choosing either from box 1, box 2, or box 3. So we are going to have, you can select from box 1, which we'll call B1, and the probability of choosing from box 1 is 1/3, as we have said, right? Or you can select from box 2, which we'll call B2, and the probability of choosing from box 2 is as well 1/3, right? The probability of choosing from box 3 is also 1/3. So let's fill this probability. So from box 1 we have 1/3, box 2 1/3, box 3 the probabilities are 1/3. If we choose from box 1, we can either get a chocolate or a mint. So if we choose from box 1, we can get a chocolate or we can get what? A mint. So in this case, the probability of getting a chocolate, we have said that the probability of getting a chocolate, we have how many? 10 on 15 on 25, pardon. And the probability of getting a mint, we have 15 on 25. So if we choose from box 2, there are just two items again in box 2. We can have what? An apple or we can have an orange. The probability of getting an apple is 8 on 12, while the probability of getting an orange is 4 on 12. So when we are selecting from box 3, we can only have a dinosaur or a turtle. So we can have a dinosaur or we can have a turtle. So if we are getting a dinosaur, the probability of getting a dinosaur is 7 on 10, and the probability of getting a turtle is 3 on 10. Correct. So that's all we need to know about this question. So from here we are going to pick events A, B and C. So let's proceed to solve for event A, B and C. Event A says that what? For us to get event A, we have what? The child can get either a chocolate and a dinosaur. So if we have a chocolate, so if for us to get a chocolate, we must either select from what? Only box 1. So box 1 times the probability of getting a chocolate. So from box 1, 1/3 times the probability of getting a chocolate, or which is addition, or if we want a dinosaur, we can select from box what? 3. So the probability of selecting from box 3 times the probability of getting a dinosaur, which is 1/3 times 7 on 10. So if we simplify this, we are going to have 1 times 10, which is 10, divided by 3 times 25. So if we simplify that action, we can say we can simplify it 5 into 10 2 times, and 5 into 25 5 times. So we'll have 2 on 15, and in this case we'll have 7 on 30. So if we take LCM on both sides, we are going to have 30 into 15 into 30 2 times. 2 times 2 is 4, plus 1 into 1 times 7, which is 7. So 4 times 7 is 11 on 30. So the probability of B, for B, we said that B, the child gets a mint or a turtle or both, but we cannot get both a mint or a turtle, you know, right? Because they are not in the same box. So we can either get a mint or a turtle. So in this case, let's see, for us to get a mint, therefore we need to choose from box 1. So we'll have the probability of choosing from box 1 times the probability of choosing a mint. And to get a turtle, we need to choose from box 3. So the probability of choosing from box 3 times the probability of choosing a turtle. So the B event will be 1/3 box 1 times mint, which is 15 on 25, plus the probability of choosing from box 3 1/3 times the probability of choosing a turtle 3 on 10. So if we simplify this, we are going to have 5 into 3 into itself 1, 3 into 15 5 times, and 5 into itself 1, 5 into 25, that is 5 times. So we'll have 1/5 here, and then we'll have 1/10 here. So 1/5 plus 1/10, so it will give us a fraction of 3/10. So that's the probability of B. And the probability of C, which says that you can just get what? An apple. So to get an apple, we must choose from box 2, and then the probability of getting an apple. So for us to get an apple, we'll have the probability of choosing from box 2 times the probability of getting an apple, which will give us 1/3 times 8 on 12. And if we simplify this, we are going to have a probability of 2 on 9. So those are the three probabilities for A, B, and C. So we can therefore start solving for the event 1, which is A intersect C. So for us to do this, let's again list the probabilities of A, B, and C as we have solved on the previous slide. So in this case, we have A equals to 11 on 30, probability of B is equals to 3 on 10, and event C has 2 on 9. So the A part of this question says that we should look for the probability of A intersect C. So A intersect C will be 11 on 30 probability of A times the probability of C, which is 2 on 9. We know that, right? A intersect C, they are what? Independent events. So 11 on 30 times 2 on 9. So if we simplify this, we are going to have 22 on 270. You can further simplify this, no problem, or you leave it at that case. So in this case again, we are going to look for Roman 2. Roman 2 says we should look for the probability of A intersect B. So again, independent event, so A times probability of B. So the probability of A intersect B is probability of A times probability of B, which is 11 on 30 times 3 on 10. So if we multiply, we are going to have 33 on 300. You can again simplify, or we leave it at this stage. So probability of getting the C part, which is probability of B intersect C, will be again probability of B times probability of C, which will give us 3 on 10 times 2 on 9. So if we multiply 3 times 9, we are going to 3 times 2, we are going to have 6 on 90. Again, we can simplify, or you decide to leave it like this. Okay, the fourth part of this question, which says probability of A union B. So since we know probability of A intersect B, probability of A union B will be probability of A plus probability of B minus probability of A intersect B. So probability of A union B will be probability of A plus probability of B minus probability of A intersect B. Okay, if we have this, then probability of A union B, probability of A is 11 on 30, probability of B is 3 on 10 minus probability of A intersect B, which we have solved to be 33 on 30. So in this case, we look for LCM. The LCM is 300. 300 in 30 into 300 is 9. 9 times 11, 99. No, 30 into 300 is 10. 10 times 11 is 110. Plus 10 into 300 is 30. 30 times 3 is 90. Minus 300 into 300 1 times minus 33. So if we simplify this, we are going to have 167 on 300. If you can simplify, you can. Roman 5 says we should look for probability of A union C. So again, it will be probability of A plus probability of C minus probability of A intersect C. So if we have those probabilities as we have on the right, on the left, we are going to substitute them. So probability of A union C will be equals to probability of A, which is 11 on 30, plus probability of C, which is 2 on 9, minus probability of A intersect C, which is 3 on 10. We are going to have that. The LCM in this case is 270. So we'll look for the LCM. 270 into 30 into 270 is 9. 9 times 11, 99. plus 9 into 270 is 30. 30 times 2 is 60, minus 270 into itself 1 times 22, 22. So if we simplify this, we are going to have a probability of 137 on 270. So guys, that's how we handle questions like this. Thank you for watching. If you are a new subscriber, don't forget to subscribe, hit the notification bell, comment and like my channel. Share with others who need videos like this. If you are an old subscriber, thank you for following up to now. Stay with me and remain blessed. Bye bye.